Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of rational function. As per the problem, sketch the function f at x equals 1 over x minus 3 and then write the intervals where the slope is increasing and decreasing. The first step is to identify the key features of the graph of this function so that we can sketch the function. So the first key feature is intercept. Let's start with x-intercept. We can find the x-intercept for this function by setting the function value equal to 0 and solving for x. We can cross multiply the denominator, x minus 3. 0 times x minus 3 is equal to 0. Since there is no x term in this equation, that means this function has no x-intercept. Now we can find the y-intercept. For y-intercept, we should sub in x as 0 in the given function. Zero minus 3 is equal to negative 3. Which is equal to just negative 1 over 3. So the y-intercept can be written as an ordered pair as 0, negative 1 over 3. Next, we can find the asymptotes for this function. Let's start with vertical asymptote. For vertical asymptote, we should set the denominator expression equal to 0 and solve for x. I get x equals 3. Next, we can find the horizontal asymptote. The degree of the numerator expression in this function is 0 because there is no x term in the numerator. The degree of the denominator expression is 1 because there is an x term in the denominator. Since the degree of the numerator is less than the degree of the denominator, that means the horizontal asymptote for this function is at y equals 0. This is a very important concept we need to understand and memorize to solve this type of problem. Next, we can analyze the end behavior of this function around these asymptotes. Let's start with the horizontal asymptote. For horizontal asymptote, we have to analyze the behavior of the graph on the left and the right side of the x-axis. We have to check whether the function approaches the horizontal asymptote y equals 0 from above or below. So we have to use test values. For the left side, we can use a big negative number. We can sub in x as negative 100 in the given function equation. Negative 100 minus 3 is equal to negative 103. The value of this fraction is negative. Since a negative value is less than 0, therefore the function approaches the horizontal asymptote from below. We are doing the comparison with 0 because the horizontal asymptote is at y equals 0. Next, we can sub in x as a big positive number. We can use x equals 100. This fraction has a positive value. Therefore, on the right side, the function approaches the horizontal asymptote from above. Now we can find the end behavior for the vertical asymptote. We have to check the behavior of the function on the left side and the right side of the vertical asymptote. For the left side of the vertical asymptote, we can use x value very close to 3 but less than 3. We can use x equals 2.9. We can sub in this x value in the given function equation. Value of this fraction is negative. Therefore, on the left side of the vertical asymptote, the function approaches negative infinity. Now we can do the test on the right side. We can sub in x as 3.1. This fraction has a positive value. That means on the right side of the vertical asymptote, the function approaches positive infinity. Now we can use all of this information to sketch the function. We can start by showing the intercept. There is no x-intercept and the y-intercept is negative 1 over 3. So somewhere here. The vertical asymptote is at 3. The horizontal asymptote is at y equals 0 or the x-axis. Next we can show the end behaviors. On the left side, the graph should be below the horizontal asymptote. On the right side, it should be above the horizontal asymptote. On the left side of the vertical asymptote, it approaches negative infinity. And on the right side of the vertical asymptote, it approaches positive infinity. Now we can join these end behaviors. So this can be the sketch of function f and x. Next, we have to write the intervals where the slope is increasing and decreasing. We should use tangent lines to identify the intervals where the slope is increasing and decreasing. Let's start by analyzing the curve. In the bottom left corner, we should draw tangent lines on this curve. The tangent lines will look something like this. We can see that the slope of these tangent lines is negative because from left to right, these tangent lines are sloping down. And these tangent lines are becoming steeper as we go from left to right. So that means the slope is decreasing from negative infinity to 3. We can also write this interval as. Now we can analyze the second curve in the top right corner. Let's start by drawing the tangent lines. As we can see, these tangent lines have negative slope because they are sloping downward as we go from left to right along the tangent lines. And these tangent lines are becoming less steep as we go from left to right along the curve. That means the slope of this curve is increasing as we go from left to right because the slope of the tangent lines is increasing from left to right. For example, from -3 to -2 to -1. So these values are increasing. So that's why the interval of increase is from 3 to positive infinity. We can also write this interval as. So there's a very tricky concept which needs to be understood and memorized to solve this type of problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.